So hello, sorry for the delay. There has been some technical issues with my Wi-Fi. I will show you a demo in the second part of my presentation if you get there. So hello, my name is Balazs Gaspar. Oh, 1 second. My name is Balazs Gaspar. I work at Cloudera in Budapest, in Hungary. And I'm very happy for Axiom to invite us to this conference. My topic is data science on the Cloudera platform. And just a little bit of background. Who knows Cloudera? Please put your hands up. Okay. Who is a data scientist in the room? Okay. Who is working in data scientist? Anybody who knows Python or R? Great. Okay. So I will call you a data scientist from now on. Okay. Anybody who works in IT operations? Great. Okay. Anybody who works in IT in general? Okay, good. Thank you for the short poll. So my presentation is about a very specific topic, and this is about data science and machine learning at scale in a large organization, like an enterprise. And data science is not a new topic. You know, it has been around for decades. It was just called a different name. But now the fundamental change is that, as you can see on the graph, we now have data available, we have processing power available, and therefore now we are seeing the golden age of data science and machine learning. So we at Cloudera see that Spark, Apache Spark, is one of the key fundamentals of distributed computing, and it's also the de facto industrial standard behind distributed data science or machine learning. And we have Spark in our platform. It's been there a while, but Spark itself is lacking certain features that makes it user-friendly, that makes it accessible for data scientists. So, to give you some context, you probably understand the general workflow of how data science is being done. It's built up of 3 different parts. One is called data engineering. One is enabling data science, exploratory data science. And finally, moving machine learning into production. I will focus on the second part, but we believe the data engineering part, the first one, is already solved. We have terabytes, petabytes of data available. The technology behind is Hadoop. There is a scalable technology. And as you may know, Cloudera is the leading vendor of Apache Hadoop. We have a Hadoop distribution which enables distributed storing and distributed processing of structured, semi-structured, unstructured data in basically unlimited capacity. And this can be done in the cloud, this can be done on-premise. Let's assume you already have the data in whatever format you are collecting it. The second part is also partially solved. There are already building blocks available for doing data science, doing data analysis, using open source tools. I'll get to this later on. But what we see, that the last part, which means actually putting machine learning into action, so moving the results of some sort of exploratory, iterative data science, of putting this into production and making business value out of this, this is a step that is typically not happening. So just a little bit of summary of the situation, what we see out there in the let's call it market, or in the IT world today. There are some good news. We have capacity available for distributed data. We have the processing power available, and this processing power is affordable. This is available. This is basically with commodity hardware, so you can buy, or your organization can buy cheap hardware, or leverage the capacities of a public cloud environment, name it Amazon, Azure, Google Cloud. You have infrastructure there, so you can collect your data, store your data, and process this data. In the second block, there are open source languages like Python and R, which are more than 10 years old. But recently, there have been also a huge explosion in the different libraries and packages available. I'll stop here for a second and ask you, who is using Python on a daily basis? Just again, how many of you? Okay. Who is using R on a daily basis? Okay. Anybody using Scala to write programs? Okay, I see just a very few. Java for data science. Okay, anything else like H2O, TensorFlow, Keras? Okay, also in the background. Okay, so I see mainly in this room you have a strong Python focus. For those of you who know Python, it's a language, it's a simple scripting language. And if you want to do number processing on a large scale, you don't need to write your code from scratch. You have open source libraries available. You can reuse them. You add your own data, and you can do you can apply a certain machine learning algorithm without needing to recode the algorithm. You can just need to parameterize it, apply it to your data set, and you can have actually results in a very short time frame. Of course, it's an iterative process, but all the tools that you need already exist today. And last step, it's also available. Hadoop has been around now for 10 years. Spark is over 5 years old. And these technologies are nowadays very connected. Spark as a distributed processing language runs on Hadoop clusters, and it's, let's say, the de facto technology in the industry. So these are the good news. Many, many components are available to do data science and machine learning at scale. However, there are certain blocker issues that we see. And let's start with the following. Those of you who know the basic concepts of Hadoop, is that we want to bring compute, so processing, to where the data is. So if you have distributed data, you don't want to move the data, you want to move your computational tasks to those servers that are hosting the data. This is the fundamental concept. However, in the data science world, we see exactly the opposite. We see that whenever somebody wants to do a data science project, his environment will be mostly his laptop, like mine here. And what you're trying to do on your everyday work is moving the data and putting it into your notebook, or your laptop, to make it work. And this creates so-called data silos. You may have some data warehouse, you may even have some cluster, Hadoop cluster, but when you want to run Python to analyze the huge data sets that you have there, you will most likely work on your notebook. Second, typically data science teams, they use different sets of tools, different languages. So most of you in the room, they are Python users, but you can very well imagine that even in Python, it's not a unique environment. You have those who prefer 2, those who prefer Python 3, those who prefer these libraries to get the work done, those who prefer a different one. And even if you can agree on the certain environment that you use in a team, you might have versioning issues. Someone who joins your team might want to do the same work, but it will be difficult for them to set up exactly the same environment like you have, because they need to configure all the dependencies. Okay, there are tools out there that help this simplify, but basically it's a very large ecosystem, and it's difficult to maintain the environments in which you are working with. And because of these reasons, when you work on your notebook, you can work with, let's say, gigabytes of data. You can work with anything that fits in the memory. But if you want to work with petabytes of data, how do you do that? So to summarize, in three key topics. So access to the data. It's not just about the size. So as I mentioned, if you have a data set that fits here, that's good. But if you have a bigger data set, how can you analyze it with Python? And second, let's assume you have some sort of sensitive data or some sort of data that requires security. How can IT provide data scientists the chance to use their tools that they already know, the tools that they trust, but in the meantime, make sure that they can only access data and only that they are supposed to access, and that when they are doing it, it's also auditable, it's also compliant, and so on and so on. So there is a mismatch already in the access area. Then the second is scale. How can you leverage all the resources that you have in a cluster? You have hundreds of gigabytes of memory in a distributed system. You have dozens of cores of CPU. How can you leverage this? And even if you leverage this, how can you make sure that those who use it respect resource management? I mean, that They are not taking away resources for the computations from others. This is a second topic. But also scale has a human aspect. Because now CPU scales, okay, memory can scale, the storage can scale, but people are difficult to scale. People can scale if they can work in teams, and typically data science is a team activity. But with the tools that are available, it's very difficult to set up a common environment where people can work together on the same Python code. Okay, you have GitHub where you can put all your codes, but if you really want to work together, you want to have the same environment, which is maintained centrally. And finally, developer experience. The tool that we are looking for needs to be similar to the tools that you may be using already. So if you know Jupyter, if you know Zeppelin, these are, let's say, very well-known open source tools. You want to have something similar. So therefore, at Cloudera this year, so in 2017, we have this on our agenda. And myself, as a systems or sales engineer for the region, in Hungary, in Poland, in Czech Republic, and all the other countries of Central Eastern Europe, we see a huge demand for this. So there are many, many enterprises that want to use data science, but are suffering with exactly the same problems. So what we are trying to achieve, and I'm going to show you a tool, a concept and a tool that we have developed. What we are trying to achieve is to help more models to be deployed in production. So the effort that's already being done to help business value come out of this. But this is not easy. So as I explained, there are data scientists who want to use their existing tools, who want to use whatever gets the work done. So you find a library, it helps you answer your questions. You want to use this at scale. On the other hand, IT, and this is why I asked IT operations, IT wants to make sure that the shared resources are used. So if you are fortunate enough to have some sort of cluster already in place, the biggest question is how you drive consumption. How do you make users actually use the resources and the data in there? So IT needs to make sure they have users, and these users are not just BI users or not just people who look at dashboards, or not just ETL processes that run every night. It's also data scientists who should be using this data and these resources. But as I said, this has to be in a manageable way, in a way that's acceptable for IT and for IT management. So, without much ado, let's just summarize shortly what would be an optimal situation. So, give access to distributed data, distributed resources for data scientists, but don't compromise the tools that they already know. Make sure that they can work with these tools. And for IT, drive consumption, avoid data silos, make sure that everybody who wants to access a certain data set can access the central data set without copying data around, and make sure, however, that this access is done in a managed way. So what we have done, we have released in April a tool which is called Data Science Workbench. I'm not going to promote the tool right now too much. You understand the concepts that I displayed. Basically, the tool is solving exactly these problems. And just to show, I'm going to show you now a demo. So you have some sort of understanding how this actually works and what are the concepts behind. So I think I may need to copy my screen. Okay, 1 second. Okay, maybe I just need to close this one. Okay. Okay, good, then let's do it this way. So, this may be a bit slower for me, but okay. So the tool you see here, can you see in the back row, or should I zoom a little bit? Okay. So The tool you see is called the Data Science Workbench. When you log in, you see on the I'll zoom a little bit. On the top, you see the resources that are available for data scientists. So this means, let's assume you work in a team and you want to run Python projects. This is very simple. So if I wanted to do some pilot projects, I just start a new one. I call it Hello DataMass, just to show you the capabilities. And I'm going to make this a public project, which means this is something I can work together in my team internally. So I can share the code, I can share the environment with them. And to show you a feeling, I could start with a blank project without any kind of data in there, or I could start by uploading some sort of project that I already worked with in my computer. I could also clone a project from Git. So it's possible to collaborate with some Git repository to clone the project and then push it back when I make changes. But in the tool, we also have some templates that are ready-made that can demonstrate the capabilities. So this is now some ready-made, very simple Python project. And you see I have some files here already in the project. I have Markdown support. So basically, just like in GitHub, if I write some README MD file, it's possible for me to see the contents. I can change the files from here. But basically, this is not the main concept. The main concept is I want to run this project, this code, these scripts interactively. So I'm going to start up a session, how we call it. And this session is basically, this session is a virtual, it's a container. It's a Docker container that's running in the background. However, this is something that only works when I'm in my VPN, and my VPN doesn't work now. So this is why I was a bit concerned. This is something running, by the way, on Amazon. So I have this, I have a Cloudera cluster that is set up on AWS. And what I'm doing, just give me a second. Sorry, just 1 second. Okay, so maybe that it will now be better. So what you can see in the meantime, this interactive shell has started. So maybe it's when I have switched connections in the background from my mobile to Wi-Fi, which is now working finally. So continuing, I have a cluster in AWS, and this cluster is made up of multiple machines, and these machines are hosting data. And I also have this application running in the cloud. And this allows me to run, as I'm showing you, Python code. So for instance, if I open this demo Python, I can just simply run it. And what it does, maybe I go through and explain what it does. It is loading Python libraries on the fly. So I'm now working in a shared environment, which is not running on my notebook. It's running on resources somewhere in the cloud. It could be on any cloud, but right now it's AWS. And I am able to customize this. So I'm able to add new libraries on the fly. And then, like the very popular Pandas library in this instance. And then I can do some example code. Like here, it's a regression. Here, it's some Google Maps API integration. I'm just inserting some examples. That basically what I can do here, I can do interactive scripting with data that I have available at small scale. So this is not really new. The nice features, however, is that if I go back to my project, I can go to team settings, and I can enable others to work with this. So for example, I can add here my boss. I can make him a collaborator of my project, and this means we can now work together on the same Python code without him needing to copy my environment. This is just one thing. As you may have seen in the beginning, when I set up a project, I have multiple options. So now I'm going to go back and create a different project, and I'll show you some details. So let's call it Hello DataMass Spark example. So now I'm going to use something which is based on distributed data and distributed computing. And now we also have a template available, which is in PySpark. And this has a bit more examples here. So when I say I want to run, again, an interactive session, I didn't explain this before, but maybe I'll just spend a few minutes here. So when I start a session, I had a chance to decide for my project, do I need a container? Do I need an environment which is a Python, which is R, which is Scala? This is free to me to choose. And these environments, however, these are not burned into the system. So for those of you who know Docker, it's possible for me, as a data scientist, to customize this image. And without the need to talk to IT department and ask them to install on the servers certain packages or certain dependencies, I can do it in a Docker image, and I can upload this Docker image into the application. And then whenever I start a new session, all these settings will be there. So in the admin interface, it's possible to change the actual containers. I also have the chance to select how many resources I need. So for instance, for this demo, I will only pick 2 vCPUs and 4 GB of memory. It's not much. But in my cluster, I have much more resources. So instead of working on my laptop, I already get a virtual environment, which is hosted locally, and where I can utilize much more memory and much more CPU for my session than what I have on my local notebook. But this is still just the beginning. So let's assume I need even more capacity that I have available in a Docker container. So in this case, I'm going to show you an example, a very easy example of the word count program. How many of you know word count? Okay. So word count is basically just let's say a hello world application for data science. What it does, it takes a text file, some random text, and it counts all the words. So it just counts how many what kind of words are there in the text and how many times do these words actually appear. Now this is how this is done is that we are loading here what's important, a PySpark library. So I'm working in Python, but in some parts of the code I'm reaching out to Spark. And for those of you who know Scala or you know how Spark is working, I can write some snippet, some part of the code, which will be executed in a distributed way. So if my Word, this is of course a very simple example, if my Word file would be very large, terabytes or petabytes large, I could run the same code to analyze this Word file. So as you can see here, it's a very simple RDD with a map and a reduce step. As I said, this is the Hello World program for every Spark application. So I can show you what happens when I run this. For those of you who have used Spark before, now my Spark code is my Python code is reaching out to the cluster, which is, as I said, a distributed system. Is now reading from HDFS, which is the Hadoop distributed file system. It's reading a file directly from HDFS, and now it's running a Spark code and then just basically giving the results back to my let's say my session. So in the background, what's happening is that, and maybe I can switch to the cluster. I just need to create a tunnel to my cluster. I hope this works. Yep. So there is an option here to actually check the Spark history. Okay. Okay, I'm having VPN issues. So, but I would be actually able to connect to the cluster and see how this spark job in the background was executed. I'm not going to be able to show you that right now. So instead, maybe I'll show you what is happening in the background. Okay? Come on. Okay, I have the terminal here on the wrong window, so I'm going to pull this in. Okay, so if I click there, I get a terminal access to my environment. And here, if I say, what is this environment, you see that it's basically a very simple Linux operating system. But the nice thing is that my project is mounted automatically in this small container. So, and in this small container, I can do whatever I want. So I can connect to the internet and download any packages. And locally, when I'm working in this environment, I can set up my Python environment the way I want to. So this is, as I talked in the beginning, this is the flexibility that data scientists want. Now the question is, what happens when I want to interact with the data? How is it guaranteed that I can only use data in a secure way? And the nice thing is, I don't know how many of you know Kerberos, but if I would say, I would ask the server, okay, what is my identity here actually? Then it will show me, okay, your name is B. Gaspar, which stands for my name, Balazs Gaspar. And this is my user on this environment. And when I want to run a Spark code that is reading data from the distributed environment, from HDFS, then this will be the user that is authenticated in the cluster. And basically, whenever I want to interact with data, I am only able to access data on this cluster, which is authorized for this user. So basically, for those of you who don't know Hadoop, this may be a bit complex. But basically what's happening is that I have an existing Hadoop distribution, which is fully secure, which is where authorization settings are applied. So it means I know what users have access to what data. And those users were running SQL before or using ETLs before. And now what I'm doing is I'm giving these users a tool to run any kind of Python code. But whenever they want to read data from the cluster, they can only access it in a secure way. Moreover, since I'm authenticated on this cluster, if I want to run a large-scale application, like some more complex machine learning, which I'm not going to do now, but if I were to run some more difficult applications, since my Spark application is running on my name, I could only use the resources, the memory, CPU, or network resources, which my user, which is probably in a data scientist user group, is allowed to do. So basically, it is whatever I do is done in a managed way. It's a pity I can't open. It's a pity that this is not working, and I really wonder why it's not working when it should be. But nevertheless, what I wanted to say with this, there are resources available, and I have the flexibility to work with those resources, but not just me, but also other users can set up their own environments and work with these resources. I'm going to show you one more feature in this tool. Let me get back to the project view. And as I said, here in the team view, I can set up different users. Like, let's add one more, another colleague of mine who will be a viewer. Let's add again my boss, who will be an administrator. And now these people can work with the same project with the same code. So how I would work with this is normally the following. I set up a Github repository where I'm putting my Python code. Let's say my initial master repository. Then I can check out the code here. And then whenever I change something in the code, I can simply go back to the terminal, not this one, but I can simply go back here to the terminal and push the code back into GitHub. And in the meanwhile, we can work together in the same environment. This is one thing. The other one is when we create some sort of work, it is very easy to share it with others. So if I say, I have here this session running, I can always switch back here and see my data here. I can still say that I want to see the results of my last execution. And it is still there. So even though the Spark job in the background has stopped, I can still work with my session because it's still running. I can say, hey, let's share this with others. So if I want to say, let's go back to the top and share the code, I can generate a link. And I can easily show this to somebody else who is not a data scientist. And then simply, I can send over the code to colleagues of mine, and they are able to see what I have done in read-only mode. And whenever I do updates, people can also see this. Okay, so much for the demo. Basically, I wanted to show you how this works. I think I will answer some questions in the end, but I would like to go back to the presentation and conclude what I have explained. So, what we are providing data scientists is to use their existing tools, existing packages. You can also extend this. So if you on the fly want to add something else, it's possible. You don't need to reach out to IT, or even in case you have, and we see this actually happening in an enterprise, because this tool is being used in large companies like banks, like other financial institutes, even in our region. What we see is typically there's a controlled environment. So IT would like to create a local repository where they install some sort of Python libraries that can be used. And then whenever a data scientist wants to customize the environment, they can simply browse this repository or download libraries from this repository. They don't need connection to the internet. They can use the local repository. But still, they can customize their own environments. Out of these interactive shells, which could be Python, R, Scala, you have a direct access to the cluster. There is no need to integrate this additionally. So it means you have a cluster ready, you just install the Workbench application, and you can start working with your existing data and your existing authorization settings, security settings. There is no need to change anything. And what I didn't show you now, you have the possibility to create jobs. So there is automation possibility. You can set up workflows, or you can set basically single jobs that run some script in an automated, scheduled way. You can set up in the tool, there is a support for workflows, so multiple jobs triggering each other. And then this can be automated. Actually, this demonstration, this is from April, and some things have already changed. Now we already have support for GPUs. So if you have machines in the cloud or on-premise that have GPU cards inside, you can run machine learning or deep learning libraries, like you can use TensorFlow. You can include TensorFlow and write code using TensorFlow, and your code will leverage the local GPU resources. And just like with CPU and memory, you can decide for a certain session how many cores, how many memory, or how many GPUs you want to add. So again, you don't need to work with your laptop and put GPUs in your laptop on your standalone machine. You can put it in your cluster and then use this application to work with it. And again, how you can move machine learning to production, of course, it's a general question, and I will conclude that shortly. But with this, you can also automate your jobs through a REST API. So basically, you can write your own programs that can trigger jobs that will be executed in the data science workbench, Python or R or Scala environments. Okay, and on the other hand, this allows IT to give the freedom to data scientists. On the other hand, manage the resource usage, manage the data, make sure that their data is secure and the access is in a compliant way. And with this being done, it is now possible to actually put the models that data scientists have developed into production and to run these models next to other critical workloads. I'm not going to go through this slide, but this is very, very simplified. The whole ecosystem is very complex. There are distributions like Cloudera who help you to make Hadoop and the whole Hadoop ecosystem, including Spark, including different security components, now including data science. Much more easy, but of course it's a full stack problem. There are many, many concepts that you have to consider, but it's good to have an overall platform that takes care of all of these problems. And again, this is open source. So the tool you have seen, this is available to Cloudera customers. But everything that you develop, it's open source, it's portable. So your existing Python and R code will run here. You can move your code away from this application. You are not tied to this application. Also, you have a freedom of platform. You can have a cluster locally for every data that cannot go into the cloud. Of course, this cluster will not scale. But it's possible that for certain jobs, for certain, let's say, model building jobs, which do require lots of resources but don't run all the time, you can spin up clusters in a cloud environment. You can set up the same environment and then run your jobs in a cloud cluster, get the results back and shut down the cluster. Or, finally, if you don't have local resources, you can set up an AWS and Azure cluster and install this application there. And then you have a data science platform where your data is in S3 or Azure Data Lake Storage. And you have a very, very flexible cloud data science environment, which you can shut down when you're not working with it. You can save costs, and which has all the benefits which I have explained to you. So thank you very much for your attention, and sorry for the technical interruptions. That was not intended. I did this demo lots of times, and today it was maybe a special day. So thank you very much for your patience and for your attention, and I'm happy to answer any questions.